Okay. Six 6.2. So 6.2 is the most important section, I'm just going to go ahead and say.
Thank you.
So it's the most important section because it's going to show up the most often, and we're going to reuse it over and over and over in every chapter after this. So really, really, really focus on getting 6.2 down like the back of your hand, okay? All right. So 6.2 is factoring trinomials with a lead coefficient of +1. Okay. First we're going to start with the main method, and then after that we're going to say, what if they had a common factor? What if there was a negative? And basically take out the GCF first. But there's only one method here, hidden behind 2 or 3 problems that might look different, but really there's only one type of problem here. So first I'm going to multiply one out, and so you can see the pattern. So here's x plus 3 times x plus 5. Okay, I'll write a couple things to notice after. But x squared plus, just distributing, plus 5x plus 3x plus 15. We combine these middle two. We get x squared plus 8x plus 15. So just a couple things to notice here. You could do lots and lots of examples. Not to waste your time, I want you to notice a couple things. The lead coefficient in both of these is +1. So, +1x times +1x equals +1x squared. That's the easy part. We know these for this whole section. That's what makes this section easy. And then we also notice that this resulting third term is the product of 3 and 5. And the resulting second term is the sum. Okay, so that's how we're going to hunt for these numbers. Basically, because the lead coefficient is +1, we know that the first term is 1x, and we know this is 1x. So all we are searching for so in factoring, we are searching for these numbers. And that's the whole game we're going to play here, is trying to find those two numbers. So, I'm just going to raise a teeny bit of this. Sorry. Okay. So here, how to factor. Let's start with number 2. Nice straightforward one. 2x squared plus 7x plus 6. Okay? So, the coefficients here are +1, which we need, +7, and +6. Okay? We're going to use these. We need this to be +1. And then this is going to be our sum, and this is going to be our product. Okay, so the way I write this is I know that the sum is gonna be positive 7 and the product is gonna be, whoops, I wrote the product way too high, is gonna be positive 6.
Set aside.
Sum, my bad. Okay, is positive 7 and the product is positive 6. And we are looking for two numbers. One here and one here. And so this is the way I write it. Okay, I call this x factoring because I write a big X. And I know that my resulting factor, because we have this positive 1, is going to be 1x plus something times 1x plus something. The whole reason we know that is because what are the only things that multiply together to make positive 1?
Positive 1.
Yeah, 1 times 1, that's it. Right, you could argue negative 1 times negative, and yeah, that would take us down a whole rabbit hole of being redundant and say, okay, well then every time we say 3 times 4 is 12, we'd have to say negative 3 times negative 4 is 12, but we're avoiding that. Okay, so the only things that multiply to make 1 are 1 and 1. So we know the first term. That's why this is so helpful. That's why 6.2 is so common and happens so often. 6.3 is all about what if there's a 6 here, or a 5, or a 2, what do we do then? And that's harder, significantly harder I would even say. Okay, so what two numbers are they? Alright, what two numbers multiply to make 6 and add to get 7?
6 and 1.
Yeah, 6 and 1. So over here, x plus 1, x plus 6, so we have, our answer is x plus 1 times x plus 6. And we're done. Now really easily you could multiply that out and check your answer. X times those would be x squared plus 6x. Multiply them out, x plus 6. So that would be x squared plus 7x plus 6. Check, it worked. Okay, so really quick way to check your answer, walk out on test, knowing you're right or knowing you're wrong.
Say that again, looking like
So,
how to get 6.
so we factored this by saying, okay, the first one's positive 1, got it. So our two numbers that we're hunting for here are, we're gonna have x plus some number times x plus some number, okay? And the way we're gonna find those two numbers is they add up to be this, and they multiply to be this.
Oh, okay.
Alright, so we say the sum is positive 7, the middle term, and the product is positive 6. Now we'll do a bunch of problems practicing this, but this method is gonna be the vast majority of all times I say factor. I mean, this is gonna be half or 2/3 of your problems. Okay. Alright, so let's do a couple examples.
So it's the product that has to add up to the sum?
No, the two numbers. So we're looking for two numbers. They multiply to be 6, add to be 7.
So like you can do like 7 times 1 would it equal 6?
Yeah, exactly. If you tried 7 and 1, they wouldn't have a product. So what I would do is I would always start with the product. I would go 1 times 6 or 2 times 3 are your only two possibilities.
So that would equal 5?
Yeah, you add these together, wrong sum. Add these together, right sum. Yeah. Okay. Alright. So, I'll write the method and we'll do another example. I call it the X factor, just because I like giving fun names to these things. Okay, so number 4 is x squared plus 9x plus 14. Okay, so I say this is the sum. This is the product. So I know it's equal to x plus some number times x plus some number. I'll write in a different color. It's the same format every time. It looks like that.
So the middle term is always gonna be the sum.
Exactly. So we get the sum is positive 9, the product is positive 14. I always write the positive or negative sign, because if you say, oh, it's positive, I don't need to write the sign, and you just kind of don't write it, what happens is when it's a negative, you don't write the sign, because you're already in the habit of dropping the sign and just writing the number. So I always bring the positive sign. Okay, so what are my two numbers?
2 and 7.
Yeah, so just to give you a ballpark, how I start is I list all my possible products first. Okay, so I know my only products are 1 times 14 or 2 times 7, so which ones add up? You guys already said it.
2 and 7.
Yeah, positive 2, positive 7. So I go over here and I fill in positive 2 and positive 7. So my answer is x plus 2 times x plus 7. And again, you could multiply these out to check. Okay, but right away, because that first coefficient is 1, I know it's x plus something and x plus something. It might be negative, but it's x plus a number times x plus a number. We know that format for sure. Then all we need to do is use this little puzzle to figure out what the two numbers are. Okay? And again, this will come up over and over. Now let's do another problem just with the negative sign. Alright, so here's, I gotta remember not to use green, never erases well. Alright, so another problem like 16, we kind of get into a little more strategy here. So y squared plus 5y minus 24, so what's my general format here that I start with?
Y plus something.
Yeah, exactly. So we know our answer is going to look like that, okay? So what's our sum?
5.
Yeah, and what's our product?
Negative 24.
Yeah. Okay, now here's where the strategy comes in. If the product is negative, what do we know?
Minus.
Say it again?
It's a negative,
What do you mean it's a negative?
the sign,
One of your adding negative.
One of your numbers is negative.
And positive.
And,
And a positive number.
yeah, and the other is a positive. Great, okay? So we know one is a negative and one is a positive. Okay, that's a big thing to look at first, okay? Second thing that tells us is that means when we add a negative and a positive number, are we combining them and they're growing, or are we canceling out and they're shrinking? Yeah, so really we're doing subtraction here. So my products are 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then 5 doesn't work, 6 times 4 would repeat. So those are all my possibilities right there. I got 4 possibilities. So what I'm focusing on here is subtraction. So subtracting these, the difference would be plus or minus. So I'm just going to write the number. 23, 10, 5, 2. So that's the difference between every possible pair. So sum is 5, so we're looking at 3 and 8. Right? The reason I did that is because one was positive and one was negative, so I know we're actually subtracting. Okay, so we're using this one. So I'm just breaking this down, possibly too much for you guys, but I really want to show you the mental process I go through in terms of starting at point A and logically checking everything off. A lot of times, there will be problems that you're skipping certain steps or it becomes second nature. But mentally, I always go from, okay, I got my basic format, I draw this. Do I have a positive or negative? Am I adding or canceling? list out all the possibilities, and say, okay, 2, 5, oh, there's my 5, I go up here, and then which one of them is positive and which one's negative?
Negative 3,
-3, why -3?
because negative 3 plus 8 is 5.
Yeah, because there were more what's left over in the end.
Positive.
Yeah, there were more positives left over in the end, exactly. So I know my answer is, I don't have room right here, but just on the other side here, I know my answer is y plus 8 times y minus 3, or in the reverse order, y minus 3 times y plus 8, absolutely the exact same thing, right? The order doesn't matter. What does matter is which one has a negative and which one does not. Okay? But that's the way we do it. We know because there's a positive 1 out front, this is the format of our answer. It has to be 1y times 1y for it to be 1y squared. And then all we're looking for are those two other numbers. And we use this cool little x factor method to get it. Okay? The only two quirks in this is what if there are two variables instead of one, exactly the same plan. I'll just mention it now, I'll mention it again after. But all that would look like is, what if there was an x here, and an x here, then there would be an x here, and an x squared here. Same exact plan. No differences, other than there's just an extra variable in your answer. You still have the same format, you look for the numbers the same way, you put the numbers in the same place, there's just an extra x. The only other hiccup, other than that they could add is, we just did 6.1, and what did we learn in 6.1?
Trinomials.
6.1 yesterday?
You can do it with GCF.
Yeah, find a GCF. So the thing they could add here is, the very first step, take out something that's redundant. Like, for example, they can say, oh, factor 2x squared plus 8x minus 16, and you just say, well, I can't, because I don't have a 1 there. So first, you would take out a GCF of 2, and you would say this is 2 times x squared plus 4x minus 8. And I'm not trying to get ahead of ourselves, we'll go over problems like this, but I'm just showing you, this is the one and only method in this section. Okay, and this is the bread and butter of how to factor a polynomial. By far the most common method you will use. The only thing we're going to add is say, what if there's an extra letter next to it? Same plan. What if we take out a GCF first? Great, same plan. Okay, so just want to be really clear, there's one method here and only one method. Once you learn that one method, there might be other steps in the problem before or after, but the plan is the same. All right, let's do one more example of a different combination of negatives. Okay, and the type I'm looking at is number 12. Okay, so number 12, same type of problem, but different negatives. Okay, so I know the general format of my answer here is y plus some number times y plus some number. The reason I know that is there's a 1 out front, and that's our favorite type. Okay, so we have a sum of -8, a product of +7. What does that tell us about the two numbers we're looking for?
Both negative.
They're both negative. Why? How?
So if you
It's a
multiply
product.
them to each other, they equal to a positive number.
Yeah, and when you
Add them, it's to a negative.
negative, yeah. So this being positive, as this being positive means both signs are the same. So they might both be negative or they might both be positive. So I always look at the product first, then go to the sum. So product first tells me both signs are the same, they add up to be a negative, so they're both negative. Everybody should get that check before we go to numbers. Okay? So are these adding and combining, or are they canceling out and subtracting?
So then,
Are my two negative numbers going to combine and get bigger, or cancel out and get smaller when I add them together?
Just combining it.
Combine bigger.
Yeah, exactly, so I'm doing a sum, so okay, my only possibilities are 1 times 7, I add them together, I get 8, so okay, well, I shouldn't write it like that, that would become 8, okay, so, what do I get here?
Negative 1 and negative 7.
There we go, those are only possibilities, so our answer is,
Y plus negative 1.
yeah, or y minus 1, yeah,
Okay.
and,
Times y minus 7.
exactly. And again, you could just multiply that together and check. So I just wanted to show you every possible combinations, one being negative, both being negative, both being positive. Okay, straightforward. So, the hiccup they could add then is the general form if there's 2 variables. Okay, so here's the general form. If there are 2 variables, same method. Right? Don't be scared, don't think new things, okay? So if I have a plus 2b times a minus 3b, right? And I multiply these together, I multiply my a's times my a's, my a times my b's, my b's times my a's, my b's times my b's, and I combine and I get a squared minus ab minus 6b squared. And my general format is some number of a's, or a squareds I should say, plus some number of ab's plus some number, oh, that was too tight, of b squareds. Okay? So my general format is just like I had on the other problems. I started with a variable squared, that variable to the 1 power, and that variable not present in the third term. The only way a second variable shows up is in the reverse order. Because now instead of being on the first part of this product, so first term squared, middle term being number times this, and then the last term being number times number, the only difference is now one will decrease in exponent and the other will increase. One will go from not present in the first one to present in the second one to present and squared in the third one, right? So the way I think about this is my a's are decreasing. So I have a squared and I have a and I have no a's. My b's are, I'll maybe do it in a different color. My b's are increasing in degree, so I go from no b's to 1b to b squared. Right? So that's the kind of common format that you will see, and the factored version just means I have an a on the first term, so a squared. I have a b on the second term, so b squared, and the middle combination is a's times b's. Right? Otherwise, it's the exact same method. No differences at all. Just when you write my general format here for y plus some number, it's y plus some number of x's. Y plus some number of x's. And you still find the same number, the same way. Plug it in the same place, you're done. The only difference is you write that variable. Okay, so let's do one. So here's an example. So 36 is x squared plus 6xy plus 8y squared. So what I see here is I see my x squareds going down, so x squared, x, no x's. And I see my y's going up. I see no y's, I see y, I see y squared. So what that tells me immediately is my general form is what?
Both positive.
X squared.
So we'll figure out the both positive later, but what's my general format gonna be?
X plus something
X plus something,
times,
Y.
oh, y
something y, yeah?
plus, times x plus something y squared.
No, just y,
Just
because
y.
y times y will be y squared. Yeah,
Okay,
yeah, so that's it. The only difference is this.
you just add the y,
Yeah.
the second variable.
That's it. That's it.
So
Once you
pretty
put that
much
down,
Just understanding what the equation is.
it's just kind of, the general form, maybe of the equation or the general look, but still same strategy. What matters is the coefficient here is still a positive one. As long as you still have a positive one and it's in that form, everything's okay. So, let's factor. What's our sum? Yeah, I would write positive 6, yeah. And what's our product?
Positive 8.
Yeah, positive 8. And so, signs are the same, they add up to be positive, so they're both positive. What are our two numbers?
2 and 4.
2 and 4. So, our answer is,
X plus 2 squared. X plus 2y.
yeah,
X plus 4y.
there we go. We still looked for the exact same numbers, the exact same way. The only difference was, there was a y there. If we erase that y and that y, we erase this y and this y, same answer, right? Okay. I can write that, I think it'd be too much writing, but I'll show you really quick. So x squared plus 6xy plus 8y squared, which is what we just did, looks like this. But we could erase one of those variables, okay? Let's say we erase the x's. 1 plus 6y plus 8y squared is equal to 1 plus 2y times 1 plus 4y, okay? Or let's erase the y's. X squared plus 6x plus 8 equals x plus 2 times x plus 4. So there being an extra variable in there doesn't change how you factor it, doesn't change what it's factored into. All it changes is there an x there or is there not in that general form? But you still get the same factored version, whether or not there was an x or y or both. Okay? So don't think that, don't think that there's a different method. I keep saying that, because I mean, again, in math, it's all about can you stretch your mind and do the same problem when it looks scarier, when there's fractions, when there's square roots, when there's pi, can you do the exact same method the exact same way? Okay, we'll do one more example like that. Okay, here's 42. So 42 is a squared minus 18ab plus 80 b squared. Okay? So what's our general form gonna look like?
A minus something,
Well, I'm always gonna use plus, but okay?
A plus something, B
Yeah,
times A plus something, B.
yeah. And sure, some might work out to be negative, but we're always gonna put a plus sign there, and then if our answer comes out to be -3, we put it in, and it's
Oh,
a
okay,
minus
I
3.
got you.
Yeah, okay, so what's our sum?
18, negative 18,
Yeah, and our product?
180.
There we go. And so I'm gonna list all my things. You can do this on a calculator really easily. You only need to check about 8 numbers. Okay, so I'm gonna go 1 times 8, obvious, 2 times, and what you could do is on your calculator, you could just go, 80 divided by 2 equals. If it works out to be a whole number, oh, it's 40. And then go 80 divided by 3, oh, it's a decimal, it didn't work out, okay. 80 divided by 4 equals 20. 80 divided by 5 equals 16. 80 divided by 6, oh, decimal. 80 divided by 7, oh, decimal. 80 divided by 8 is 10. 80 divided by 9, oh, decimal. 80 divided by 10 is 8. We're repeating, we're done. Okay, that's it. Foolproof method. On your calculator, you need to plug in like 8 things, and you're done. You have every single possibility. Okay, and what do we know about our signs here?
There's one.
One negative, one positive.
Yeah, oh, is that?
I mean, both negative.
Both negative. Product being positive means they're both the same, and they add up to be a negative,
Eight,
so
10.
they're both negative. Okay, so we know since they're both the same, they're combining, so adds to be 81, adds to be 42, adds to ... adds to be 18, there's our one, okay? So that's a foolproof way, a systematic approach to always get to that same right answer. So, our answer is,
A minus 8B
yeah,
times A minus 10B.
there we go. Okay, so same approach, regardless of the fact that now there were A's and B's and big numbers. Okay, same approach. Alright? And as I said, there's one extra wrinkle they could throw, because math's a big, awesome pyramid, and every step we learn, we accumulate, maybe it's like a giant snowball. So everything we learn, it just keeps growing and growing. So we just learned 6.1. So all I'm gonna say here is, remember two things. From 6.1, right? One is, oops, let's write it this way. The first step in factoring is always take out the GCF. And two is, if the lead coefficient is negative, take out a -1 with the GCF. Okay, so just remember those two things. That's always going to be your first step in every factoring problem in chapter 6, chapter 7, chapter 8. Don't remember what chapter 9 is, but I think it's involving factoring too. Okay. So, let's see, so factor 46. 3y squared minus 3y minus 18. Okay?
I was about to ask you that next, what if there's a number?
Yeah, so if you were to start and just pretend it was like this, and say, oh, my sum is -3, my product is -18, you get, oh, -6 and +3, that works, and then you would double check and multiply it back together, and it wouldn't work because there's a 3 here. Okay, so what do we do first?
Y minus something.
Not
GCF?
yet.
Take out the 3 as a GCF.
Take out the 3 as a GCF, then we'll set up our general form. So GCF is 3, so what is this now?
Y squared minus y minus 6.
There we go. And now we factor this like normal.
I have a question.
Yeah.
Where do you put the 3?
Ah, so we factored this like normal. This stays until your answer, but doesn't affect anything. So it's still there. So when we write our general form now, what's our general form?
Y minus something.
Well, I always use plus,
Plus
but sure, it's gonna be plus or minus, yeah, times.
Y plus something.
Yeah, exactly. And we're gonna leave the 3 there. So our general form now is 3 times y plus a number times y plus a number. So we took that GCF out first, and it's just there, right? It doesn't affect how we factor this inner thing. We're just looking at factoring the inner thing now. We already took that 3 out, and it stays there. Okay, so let's factor it. What's our sum?
1.
-1. Yeah.
And the product, -6.
-6, yeah, those negative signs are important here, okay? So, what do we know about our product?
Both negative.
Yeah,
Be a negative and a positive.
yeah, one's gonna be negative, one's gonna be positive, because the sum is negative. So it's either 1 times 6 or 2 times 3.
-3 and 2.
So, and we know we're really subtracting, because they're canceling out. So subtract these and we get 5, subtract these and we get 1. So yeah, it's that bottom one. Which one's negative, did you say, Brian?
-3.
-3, why -3?
Because if you minus, -3 plus 2 is -1.
Yeah, you're left over with
Or a higher positive.
more negatives. Okay, so last we have, it's
Higher negative.
plugging in our numbers. So first we take out the 3, then we factor it just like normal. So no difference in the problem, just take out the 3 first. Okay,
So you just got to do the GCF first.
say it one more time.
You got, on that number 46, the first thing you gotta do is find the GCF.
Yeah, and that's gonna be every problem, you check that. In general, the first problems from your homework, they're easy, you're not gonna have that. And as it builds in difficulty, you're gonna have to take out the GCF. Every problem, after about 40 something, every problem will have a GCF. You take out first, then you solve the problem. Just something to mention here, problem 22 is x squared plus 4x plus 5. Okay, so no GCF to take out. So our sum is positive 4. Product, you don't need to write sum and product every time, product will always go on bottom. So our possibilities are 1 times 5. But
1 is negative.
it isn't. The product's positive, so they could both be negative, but then they would still add up to not that.
No solution.
Close, it's asking you to factor it,
Cannot be factored.
cannot be factored would be how you answer. But I mean, yeah, there is no step to go further. So you would either say cannot be factored, or another way to say that is prime. Okay, I'd say most people are more comfortable with it cannot be factored, but essentially what we're doing here is exactly what we did with numbers when we were kids, right? Factor the number 6 into 2 times 3. It's the same thing with a polynomial. We're curious if this polynomial is composite, if it's made of 2 different factors, or if it's a prime number like 7. And that's the beauty of it. I mean, it's the same thing where we can splice up and chunk every number like 24 into exactly 2 times 2 times 2 times 3. That's the only way to write 24 in terms of primes. Same thing with a polynomial. Every polynomial can be chunked up into its exact factors. And that's a beautiful fact. And I mean, gosh, I could go on. But anyways, it's just a beautiful thing. So it's just like a numbering system. If it can't be factored, it's a prime polynomial. If it can be factored, please do factor it and enjoy factoring. Okay, so we got 2 more examples I'll do with you, which are just take out a GCF and then factor. Just gets a little bigger and a little messier. There's even a negative involved. Alright, 66. Looks big and scary, but it's not. Little teddy bear. Okay. So first thing we always check is what?
How many?
GCFs,
Yeah, what is the GCF here?
X, Y.
Yeah, we can take out an X, and there's only 1. And we can take out a Y, but there's only 1. So yeah. So we take out our XY, and it's just gonna stay there until the end of the problem. What do we get left over?
X squared
Mm-hmm.
minus 2x, y.
Yeah?
Not just 2x.
Yeah.
Minus 3y squared.
There we go. And so, oh, I see my x's decreasing. I see my y's increasing. So my general form of my answer is going to be
X,
Plus something.
y,
yeah,
x plus something y.
exactly. Right, and you can make it that far. That's all the hard part, right? You take out that GCF. That's your general form, and then we're always looking for the same 2 numbers the same way, right? The sum is -2, the product is -3. So I know one's negative and one's positive. My only choices are 1 times 2. Yep, when I subtract I get 2. I'm left over with more negatives, so it's -2 and -3 and +1. So I do multiply those, get -3, I do add those and get -2. So my answer is just going up here to my general format and plugging in -3, and up here plugging in +1, and there we go, that's our answer. Okay. So take out that GCF and then factor it with this one super crucial method. Okay, 70 is actually, I think, an easier problem, but it involves that whole negative thing. Negative 3x squared plus 36x minus 33. Okay, what do we do first?
Take out -3.
Yeah, the GCF is -3, so we take out the whole -3, and the negative comes only because it's in the first term. It doesn't matter if every other term is negative. If the first one's positive, we don't take out a negative. If the first one is negative, we do take it out. Okay, so we take out -3, and what are we left with?
X squared minus 13.
12. That's okay, arithmetic. We got calculators, and then?
Minus 11. I mean, plus 11.
Yeah, that's the bigger mistake. Don't mess up the negative and positive. The numbers, we got calculators for all that, but the negatives, we have to be really careful. Okay? And then we just factor this inside like normal, right? My general form is gonna be what?
X plus something,
Yeah.
times X plus something.
There we go. Again, a common mistake that people make is they pull out the -3 by division rather than factoring, and so all of a sudden the -3 is just not there anymore, and they factor the rest of the problem like it's that. That's okay, but there needs to be a -3 in your answer. You're just factoring this, you're not canceling something out completely, it's not gone. You just pull it out to make the rest easier to dissect and cut up. But that -3 is there for the entire time until you answer. A lot of people say, oh, well, I just won't write it, I'll remember at the end. And obviously, the common mistake with that is you don't remember at the end because it's a test, it's high anxiety, you're rushing, there's 20 problems, you're panicked, and ooh, and you just forget to drop it down. So write it in every step so you don't come across that. Okay, again here, sum, -12, product, +11. Signs are the same, they add up to be a negative, so I know they're both negative. My only choice is 1 times 11, sure enough, -1 plus -11 is -12, so going back up here, I get x minus 11 and x minus 1, and that's our answer. And again, you could multiply it back out. A student asked me how could you multiply this back out?
Distribute
Well, I mean, be a little more specific, but yeah, distribute what?
-3
Into where?
into X minus 11.
Sure, so distribute the -3 into here, and then?
And then you do it to X minus 1.
Yeah, and then multiply this times this, that's it. Or, I think it's easier to multiply these two first, and then put in the -3. But yeah, it's just like 2 times 3 times 4, you multiply it in any order. So if you were to multiply this back together, I think these two first, and then the 3 last is okay. But you could also send this into here, and then multiply this by this. The one thing you can't do is multiply this into all 4. Okay, you can't do that, because that's like saying 2 times 3 times 4 is equal to 6 times 8. That's not true. 2 times 3 times 4 would just be 6 times 4, 24, not 48. You can't multiply the 2 by both, because then you're multiplying by 2 twice. Okay, so just a little tiny thing. Alright, so that's it, we'll stop there, and then I'll give you like a 10-minute break and then about a half hour to work on this, because it's really important. Fix this, get it down, 100%.